Good morning. Welcome to CUTRIC's session on driverless rail systems, focusing on how to make rail safer and faster. My name is Kathy Wilson, and I'm a Senior Vice President with Parsons Corporation. I manage our Rail and Transit Solutions Group globally. Canada is home to many systems, technology providers, and manufacturers, which you'll hear from today. These organizations are at the forefront of driverless automated technologies, and Parsons is proud to be a partner with these suppliers and their agencies installing their systems. Parsons is currently providing engineering, testing, and commissioning support for the Toronto Transit Commission and the Vancouver SkyTrain, with the TTC implementing CBDC on Line 1 and the SkyTrain about to embark on its Broadway line extension with the next generation of CBDC, an autonomous signaling system. Canada is home to teams at the forefront also of systems assurance and the practice of systems engineering, a methodology that's key to implementing driverless and autonomous systems. Parsons has over 100 staff in Canada trained and engaged in these processes. I hope that you find the session informative today and enjoy your day at the conference.
Thank you very much, Kathy Wilson and the team at Parsons for sponsoring this panel. Welcome to everyone to the Canadian Smart Rail Technology Conference organized by CUTRIC. Welcome to our panel today titled Driverless Systems, and we will be discussing today how we can make rail safer and faster with the power of autonomous and connected technologies. Now, as you know, Canada was among the first autonomous rail system providers in the world with the launch of Vancouver's SkyTrain project in the 1960s. And since then, it's been a dead zone for autonomous rail. These capacities have been under leverage for too long, and today we will be joined by our leading panel of AV technology experts in rail to discuss how autonomous and driverless rail systems can help optimize operations and increase security for autonomous rail systems. So without further ado, I will welcome our panelists. So please welcome Veronica Marin, Advanced Algorithms Manager for Thales. We will also be joined by Carlo Borghini, Executive Director at Shift2Rail. We also have Andrea Mazzone, Autonomous and Automated Operations Cluster Leader for Bombardier. And we also have Millie Arpaci, VP Sales Mass Transit Mobility Management for Siemens Mobility. So let's start now with Veronica with your presentation. So I'll open the floor to you.
Thank you, Carla. Thank you for the introduction. So good morning, everyone. As Carla mentioned, I'm working in Thales Canada Transportation Solutions. So let me start talking or mentioning about what we do in worldwide, what is our presence, and then we'll go into what do we do in Canada. So globally, Thales has 80,000 people across 68 countries, generating over $28 billion in sales. 1.7 billion of this are reinvested in R&D. In Canada, Thales employs 2,000 people across 13 sites, generating $1 billion in revenues, coming from different projects that focus on areas of avionics, defense and security, digital solutions, and of course, transportation systems. This makes us a key partner for Canada's innovation ecosystem. For example, one of the 3 AI research centers that we have is located in Canada, as well as one of the 5 advanced research centers that we have globally. We're also partnering with Scale AI, supporting one of 5 Canadian innovation and superclusters. And one of our main thoughts in Canada is developing the next generation of autonomous trains. Now, what do we do in Toronto? So In Toronto, we have the global headquarters of rail or urban rail transportation. We employ 900 engineers working in major transit projects in Canada, such as Ottawa's new O-Train Confederation line, Toronto's Finch West LRT, and TTC expansions of their Wilson Yard. In Toronto, we also have 100 engineers directly focused on R&D efforts. Specifically, our autonomous team has 30 researchers developing high-integrity positioning system, high-integrity level computer vision algorithms, methods, and systems. And of course, the safety certification methodologies associated with these new technologies. Now, we really believe that the autonomous trains will be deployed before the autonomous cars. Our thinking is that autonomous cars must operate on a wide variety of surface roads, lighting conditions, must detect obstacles of every kind. They also require high-resolution reference maps that are difficult to obtain and maintain. Perhaps the biggest challenge is that they must interact or manage very complex behavioral interactions with other vehicles, pedestrians, and obstacles coming in different directions that require 360 degree view. Meanwhile, train has fewer degrees of freedom. Trains move over rail tracks, and the rail infrastructure is significantly smaller than the road infrastructure. And then this enables the high resolution maps, and so that they are feasible and they can be obtained and maintained way more easily. Rail tracks also provide a dedicated right-of-way, which limits interaction with other vehicles and pedestrians. In consequence, trains interact mostly with their infrastructure, sign, and signals in a consistent way, in a consistent fashion, and only require sensors in the front and back of the vehicle for this purpose. Now, how do we see this happening in the immediate future? We see autonomous trains will enable an improved service. We provide a safe and reliable system that will lower the cost. So how we see this happening is that we start from the autonomous, that we make the trains autonomous ready, then we start introducing the next generation positioning, and then we move to the vehicle situational awareness, recovery speed, then we progress to line speed, so that later we ultimately get to fully autonomous. And the way that we see is that 5G networks are going to be enabling this roadmap, as well as the big data networks that are going to handle the vast of the sensor data that we have to send across the system. And now, in order to realize this vision, we see the key challenges are related to making the AI and machine learning methods explainable so that they can be safety certified, as well as providing a high-performance network, which is related to the requirements of the 5G network, which actually meets our application. And then we also recognize that the LiDAR and the other sensors, especially the LiDAR, in order to maintain those high-resolution maps, needs to be also updated. But looking at the upcoming devices that are going to be available next year, we see that we can meet this challenge. Also, in order to provide or process all this data, we also require a high edge processing power that is going to, we see that the latest and recent devices are bridging this gap. And then finally, we see that the most significant challenge in this industry is achieving the safety certification that ensures a failure rate of 10 to the minus 9. We look forward to deploying our solutions that address these challenges. Thank you.
Good evening, good morning in Canada. Carlo Borghini speaking from the Shift2Rail Joint Undertaking. I will present how rail research innovation in Europe will ensure fast and safe rail. And I'm pleased to be part of this panel together with the Shift2Rail member. We had before Thales, we'll have after Siemens and Bombardier. And we're all working together in achieving this ambitious goal. The Shift2Rail joint undertaking is built around the concept of delivering increased capacity and to bring up the idle capacity we have in the rail system and to increase the overall performance via a focus on achieving the single European railway area, meaning fundamentally to maximize the performance for having a rail system and train being able to operate in the full network. This program results from the work that we defined in the objective to deliver to the clients of the manufacturers, so the railway undertaking and the infrastructure manager, the capability to deliver different type of services to the final clients, to the passenger, because at the end, rail is there to serve the passenger, is there to serve the freight business. And we have introduced this approach via an integrated Shift2Rail program, covering the different subsystems that constitute the rail system. How we are working in particular on the concept of the capacity in terms of creating safer and faster rail. Our core program is called Innovation Program 2, is related to traffic management. It takes into account and is building upon a system architecture that is under preparation and development to align with the major game changer, and is focusing on 4 game changers exactly: the automated train operation, the moving block technology, the positioning supported by satellite system and localization, and finally through a new communication system fundamentally based on the 5G technology and its evolution. And I think these 4 key elements are capable to bring together once deployed, and we are targeting deployment of such a solution as from 2022 with a regulatory framework that will be adopted by the European Commission by then, will be capable to maximize the performance of the system. But we are not yet there, and clearly we are not at the end. It's only one major step forward, the full automation and digitalization of the system to maximize the performance and to increase the safety. Clearly, we are, as I mentioned before, we are looking at the rail as a system, integrated system, and from this point of view, we are also looking at the vehicles. Because the full performance of the system comes also from the vehicle as a key component. And I want to show in particular, highlight the work developed on the wireless technology for the virtual digital coupled trams. In this case, the technology can evolve up to the mainline trains. And you can see on YouTube the video on how the technology works. And if you combine this with the other technology developed in IP2 I showed before, you can see how the rail system concept of operation can evolve. Similarly, we need to have a resilient infrastructure, and also from this point of view, the introduction of intelligence in the management of infrastructure via also artificial intelligence, monitoring via satellite, drone, robotics, are all elements that will increase the performance of the rail system. In terms of freight in particular, but I think also Andrea will mention it later on, we are also working on the major digitalization and automation. We believe that we are capable to increase the current market share of freight via the introduction of new technology solution. And in particular, we are working on the European Digital Automatic Coupler as one of the key game changer to change the way rail is prepared, the rail freight is prepared, how is operated, and how also the automation can improve the cost effectiveness of the rail freight. We are also working on new concept of wagon, propulsion system, hybridization, in particular looking also of new freight locomotive. And finally, we are looking also at the long trains that is they are limited today in Europe also from aspect related to infrastructure. Finally, the work of the joint undertaking is focusing also on the passenger experience, because at the end, the performance of the system depends also on how the passengers are interfacing with the rail system that will make available for them. From this point of view, we are introducing always more and more a concept that is built upon a functional system architecture and the concept of operation. And in this respect, we are also working on delivering this common vision in answering the new challenges coming from the policy level, and in particular the European Commission, in particular the European Green Deal, combining digitalization, decarbonization via sustainable and smart mobility. And in this respect, we are building the successful program of Shift to Rail, Europe Rail System, that is expected to start in 2021. To bring all these changes I started to mention here and highlighted here to a major scale, and in particular to demonstrate at large scale. Thank you very much.
Much, Carlo and Veronica, for those two presentations. We heard great things about how rail has to be put to the service of people, and how also autonomous train will be deployed before autonomous cars, which is very interesting. But we'll have a chance to go back to that. Now I will open the floor to Andre for his presentation.
Yes, good morning and good afternoon. It's a pleasure for me to give a talk on about how Bombardier Transportation, on the way towards autonomous or full autonomous systems, is trying or is improving safety. And as you can see from the title, I have called it Advanced Driverless Systems or Low-Hanging Fruits. And I will show two examples on that. So I'm the innovation manager and R&D coordinator, Bombardier Transportation. I am also responsible globally for the technology and innovation strategy for autonomous and automatic train operation. And in these roles, I'm responsible, of course, for the roadmaps, for the technology scouting and setting up the R&D projects, fundraising, etc. And together with Carlo, I'm involved in the several Shift to Rail projects. I'm managing some of them related to automation. I think Bombardier is very well known, especially in Canada. Bombardier Transportation is the part that focuses on railway applications. As you can see, we're around 200 cities with 500 million passengers running every day on our trains, more than 100,000 train cars and 70,000 kilometers. I think this is quite impressive. And we're all over with 61 engineering sites in the various countries. And long time already in business, since 1942. But let me come to the main part of my contribution. So with the first example, with the automatic train operation over ETCS, this is a huge challenge we have in Europe, where we face, due to a historic situation, the different systems in different countries, and where the biggest challenge is the interoperability in general for each of every train, starting from the different catenary system, from the different train protection system, but also when talking about automatic train operation, we need to look at this challenge and trying to link all the systems to build to do standardization, to develop the building blocks for this system. As you can see on the right side, the bottom, this is a freight train that is running demonstration phase in Switzerland in these days, financed also by Shift Rail, where for the first time, a heavy freight train is running automatically. Now, not autonomously, but automatically with grade of automation level 2. So you can imagine if such a train goes from the Netherlands to Italy and runs through the different networks, it needs to connect to the different systems, and this is quite a challenge, and it will take some years until we get ready for that. We are strongly involved by trying to develop all the building blocks required to do so. And with respect to safety, such a system will increase not only the capacity that we're looking at all the time, and it will reduce the energy consumption, but it will also increase safety because it's a system that supports the driver in doing his job. So it takes over, of course, it runs the train automatically, but the driver is still there. So there are two systems, like 2 eyes or 4 eyes, that take care about safety. And the next step, of course, is what we call grade of automation level for the full autonomous system. On the next slide, I show another example. It's a building block, but let me start first with statistics. On the left, we show that the European railways are among the safest in the world. In 2018, there were approximately 1,700 railway accidents with a total of 853 fatalities. Compared to 25,000 on the road. It's already very safe, but if you look into details, then you'd realize that only 65% of these fatalities involves unauthorized people on the track or cars on level crossings. Just 1 to 5% of these fatalities are passengers on the train. So the question here starts, how can we improve safety even more? And Bombardier took the step to go in that way and proposed many years ago the first assistance systems for tramways. So it's an obstacle detection assistance system that we call ODAS that scans the front of the tram and provides an alarm to the driver if there is a probability or a high risk of collision. And the systems is quite successful. It's being sold has been sold in different cities, 600 pieces until now, and we're gaining a lot of experience. Of course, this was focusing on tramways. And now we're developing the next stage, what we call Percept, also together with Shift Rail. Here, increased distance up to 1,000 meters, a huge challenge for mainland applications. So as a simple LiDAR does not help there. We need to detect the obstacles, to classify the obstacles. You need to decide with a heavy freight train if you want to stop, if you see a white object. If it's a child, you definitely want to stop. If it's a sheep, you usually just continue your travel. And then if you look at the next slides, 2 examples, we have been developing a red light detection system that supports the driver in detecting red lights. It looks 600 meters ahead, so it's quite a challenge to see if the red light belongs to your track or to the track beneath. And with approximately 93 detection rate, which is very good. At the bottom, a next step regarding shunting applications, a locomotive that here runs autonomously. It detects an object, it detects here a standing train, it runs towards, it slowly breaks down until they touch, and this helps to connect or to couple the two systems. All these systems increase safety because they support the driver as long as he's there, and once the systems become more robust, the sensor technology can become more advanced. We will see also slowly the full automation. And the biggest challenge I see there, and this is the approach to succeed, is that we need to look at the system approach. It's not sufficient to look only at the vehicle or only at the infrastructure. We need to look at the whole system. We need to work with our customers, with the operators, and test together these systems on the track in real environment. We need to start solve the balancing act. Customers want to have everything at the first instance. We need to start with small pieces, as the automotive industry does. You first have an assistance system that cruise control, and then lane assistant, and then automatic driving, etc. And long-term partnerships. And of course, And I think this is something that railways need, as other industries as well. We need to start to look into the support from knowledge that comes from outside, deep knowledge in artificial intelligence, in data analytics, in big data, and communication technologies, etc. And with that, I give the line to the next speaker. Thank you.
Thank you so much, Andrea. This was a great conversation about safety and how the technology can actually support drivers. So we'll have a chance to discuss this later as well. Now, we're going to go into our last presentation from Millie. And before Millie starts, I want to encourage our audience to ask questions in the chat box, and we will be having a Q&A session after Millie's presentation. So you can now go ahead, Millie.
Yeah, thanks. Good afternoon or good morning to the audience. Yeah, I'm happy to be here. I'm representing the Siemens Mobility, and I'm Vice President for Global Sales in Mass Transit Applications. However, in my long history with Siemens, over 30 years, I have also developed driverless systems in the 90s, the first ones, which was more people mover type of things, but I followed up this. So Siemens is, of course, a company which is dealing with a lot of areas like infrastructure, but also intermodal solution with app-based and passenger information systems. One of the famous one we have in Germany, the German DB app, is developed by a company which is now belonging to the Siemens. So we think in the future, the more and more connectivity of all the applications will support, of course, the passenger comfort. We have, of course, part of our units are also dealing with turnkey projects, rolling stock, and customer service and intelligent traffic system, which are a front leader in autonomous car driving, but I will come to this later. Looking at our business, of course, in Canada, we are expanding our business. Today, we have last year awarded the Via Rail contract, which was on the rolling stock side. And beginning of this year, we signed a contract in Ottawa to modernize the Trillium line. So we are more and more coming in an area where we would like to support, of course, the Canadian railway environment with the newest technology. Looking at our footprint on driverless and autonomous technology, of course, Siemens have already in operation a lot of driverless metro lines, and which is state of the art in the meantime, starting from Europe in Paris, Budapest, Hong Kong, in Asia, Singapore, in South America, Sao Paulo. But if you look at this, you find very seldomly projects in North America. This is, as in the beginning we heard, only SkyTrain is operating today driverless as a metro line. Where you find them more is on the people mover side. Of course, we have modernized Chicago, the people mover in Chicago airport. But most of the driverless metro applications are today outside of this area of Canada and United States. What we have, and with this was mentioned in the Shift to Rail presentation, is ATO over ATCS, and this is something where we have the first applications already running in Thameslink with an ATS and ATO operation. We are developing with the commuter S-Bahn Hamburg project an ATO over ATS application, which goes up to a driverless turnbacks. And we have tested with DB Cargo also freight trains, autonomous driving on the network of the German railway. Of course, this was a proof of concept to see how far is the technology and what we can do. On the people mover side, I mean, all people movers inside of airports or outside, like for connections, are today driverless. So this is all in all, I think, state of the art too. But coming then to the autonomous trains, which we have seen also in the presentation of Andrea, that we have tested the tram in Potsdam during the InnoTrans 2018 with an autonomous approach. And this was quite a good success, so we continue on this field. But we won't want to forget what is happening in the car industry and bus industry. Siemens, with part of the automobile field, are also busy in autonomous driving in this area. We have in our Munich Siemens campus already running a demo with the driverless car. We are participating in the German city of Hamburg with the autonomous bus, similar to what we saw in the Toronto speech today from Metrolinx. And we are active also in a Singapore environment for autonomous test field, where we provide the wayside infrastructure. Overall, the driverless technology will support to have at the end, of course, guaranteed availability, 24 hours operation, optimized throughput, so you can always have the best throughput you need. This will also improve the passenger experience. We see in, like, if you go to Paris and experience the driverless operation of the Paris line, there is quite a lot of passenger experience. You don't see any drivers, and you have the full sea of the wayside and so on. This supports, of course, at the end, the sustainability KPIs, which we have and which also the operators have, and overall improves also the safety and security of the system. Coming now, what is the future? I think if you look at the state-of-the-art operation in metro and people mover, driverless is the way to go. However, to adapt this technology to other fields will take some time. From our point of view, commuter rail will be the next one. We have the commuter rail in Copenhagen, like the S-Bahn. They are in the way to introduce driverless operation on the network, which is not that easy, as there is a network similar to the GO area, which you have in Toronto, with a lot of areas which is not covered, which are not protected. So means you have to introduce new technology, innovative technology to cope with the situation, a risk situation. The next portion is the driverless trams, where we are busy, but most probably the first applications will be running in a yard environment, driverless, and not on the streets. Going to ATO over to ETCS, as we saw in the shift to rail, the standardization is ongoing, and more applications are upcoming, and I'm sure in future we will see more of them also going not only to an ATO system with driver, but also up to a driverless level. And last but not least, the car industry is very much implementing these autonomous levels, which are defined from 0 to 5, with 5 to be the highest. However, there's a lot of research ongoing, and it will take some time, maybe more than 2 to 3 years, to see autonomous cars driving on the normal streets. Thank you very much, and I'm giving back to Carla.
Thank you very much, Melly. This was very informative, and it's really great to see all the benefits that rail can have, particularly for passengers. So now we will go to our Q&A session. Again, I invite the audience to share with us their questions or comments in the chat. So I start with my first question. You all have pointed out a lot of interesting things about the benefits of autonomous rail, but I would like to ask you particularly, what is the main benefit that would be economic, environmental, safety for driverless and autonomous rail system, including LRT, subway, and even regional rail right now and in the future, if you could summarize that for our audience. So I will start with Veronica.
That's a great question. So I think Carlos started mentioning in his presentation, and then I also touched on it. Everyone, I think, had a great presentation summarizing them. But I'll try my best to summarize them. So as I see it, in the economic, let's say, benefit is that we're going to, as we mentioned, it's going to be efficient. So we're going to be operating at the maximum, reducing operational costs, reducing maintenance costs, and the trains will be at the highest speed within a flexible network that can actually make it more affordable, so more people can actually be benefit from this. And also it will increase, that is increasing the opportunity for energy conservation. So that also provides the opportunity to regain some valuable urban space, the ones that are already used, and then it can be reallocated to green zones. At the same time, it makes it more sustainable overall run, and then it would also increase the safety level, because now we are going to be having redundant systems checking and having more a higher target, a higher failure rate than the human beings. So 10 to the minus 9 that we're actually targeting for is more than a human being can provide. So we're going for sure to decrease the stats that we were providing. I think it was Andrea. So those are the stats that we are aware of and that we're trying to reduce. So that's what we're working on these systems. So we're going to reduce that 64% of fatalities are involving authorized person. So if we bring all these functionalities, we would be able to have a very redundant system with a very low failure rate that would actually guarantee those accidents would be reduced for sure.
Thank you very much, Veronica. I think you've pretty much touched on all the presentations. Thank you so much for this great answer. I'll go to our next question, and this one is coming from our audience. So this question is for Thales, Bombardier, and Siemens. So with successful and long-lasting deployments like SkyTrain and London Docklands, why are we experiencing implementation risk now? How can agencies and industry avoid the challenges of O-Train, the challenges that O-Train has faced, and rebuild public confidence? That's a very interesting question. Does anyone wants to go first? So the question was for Thales first. But I know you've contributed already. So Andrea, do you want to add something to that question?
What shall I say? I mean, I don't know the specific case that lies behind the question. What I can tell you is that for closed systems, we as Bombardier, we don't see any big challenges. As Veronica already said, I mean, and also Mate said, I mean, these types of train run since 40, 50 years, full autonomously, and there is no issue. When we offer these systems on the market, it's never about safety. I mean, safety is well known. It's all protected. The environment is protected. It's a small system where you can make sure that all the risks are being covered. We face the problems in mainline applications or in urban mobility, but not on sky trains or we call people mover. So I'm not. I guess this does not really answer the question, but yeah, maybe somebody else can give more insights there.
Yeah, go ahead, Millie.
Yeah, thanks. Maybe I would like to add, I mean, if I said, looking at the history, when we started the first driverless operations in the 80s, even in the 80s was the first pilots, in 90s, somehow the rollout of the first line, there was, of course, in the passenger, a lot of spectacle, how they want to enter a train without a driver and so. But if you come after, I would say, 20 years of operational experience, as Andrea and Veronica said, I think I don't see this if you go to Singapore or you see in Hong Kong or even in Germany. I mean, we have in Nuremberg now in operation since 2006 a driverless line where even no platform screen doors are there. I mean, there is no protection of the rail directly physically, but of course we are protecting it by other technology that if something fails into the rail, we can detect it. So I think overall, worldwide, the safety and the availability of the systems is not a topic at all.
Thank you. And Carlo, you had mentioned the importance of putting rail at the service of passengers. Is there anything you want to add in regards to the confidence aspect of that question?
Well, I think more than confidence is the fact that to have a service that is providing the necessary performance. What we are looking now in the Shift to Rail program is to ensure where is needed a business model built around the concept of mobility as a service. As I think Veronica explained perfectly, we are looking to build up a system that is agile and complex at the same time, in the sense that we are able to use automation and digitalization to model the frequency of train and the service based on the specific needs. And also, as Mary said, the experience in the last 40 years of automation in the sector shows that it's possible. And I think today, with the new technologies that are becoming available, we are able more and more to have on-the-shelf system that can be implemented. And most probably, now the next step, as Andrea mentioned, is to bring them on the main line and possibly on the high speed. If I think about the high speed between Brussels to Paris, as soon as the driver exits the Brussels area and before entering Paris, is like a full autonomous vehicle, in the sense that unless there is an obstacle on the track, nothing has to be done. So these are really, I think, the changes that we need to bring forward. And one of the most important thing is also why this is important is also the capacity. I think today, if you look at the investment in infrastructure and how it's used, we have still a huge amount of opportunity to increase capacity on the track. And I think the colleagues are working technically on this to ensure that is happening.
Thank you very much, Carlo. We'll go to our next question. This one is a very interesting one for Millie. So Millie, you mentioned that most autonomous metro applications are outside of North America. Is there a specific challenge in North America, and here I would specifically say in Canada, holding back the adoption of autonomous trains for metro applications? Is there anything in particular in North America environment that is a challenge for the adoption of these technologies?
Yeah, thanks, Carla, for this question. This is, I think, what we are recognizing, of course, if you look at the development worldwide. I think in US, we see that, of course, the major operators like New York and San Francisco or Los Angeles have a lot of problems to get their old systems modernized. I mean, to increase their availability overall. So there is no thinking at this stage to implement driverless technology. If you go to Canada, I mean, the first line was SkyTrain, as we all know, and since then there was more or less nothing comparable developed in the Canadian market. And I assume that the next projects are in the pipeline, and Metrolinx looking, of course, to further lines which could be driverless in the future. But if you go to a GO Transit area environment, this will be, like Andrea or Carlos said, it will be difficult, of course, to implement driverless technology in such an environment, and will take time. I don't know.
Thank you very much.
Add me, you are Canadian, you can maybe you're more close to the market here.
All right. So we'll go to another question. Some of you have mentioned the aspect of standardization. So how standardized is this technology? This is very important. If subways or LRT systems operate on proprietary or unique driverless systems locally, that's not a problem. But when they cross provincial or state boundaries, like via rail or Daiban, what happens to the driverless controls, and whose job is it to standardize that technology in the communication software or networks that support that technology outside of the train? So I think, Carlo, you had mentioned the importance of standardization and interoperability. So can you add something to that question?
Yeah, so thank you, Carla. If we look at the main line and the high-speed network, the freight network, in Europe we are deploying ERTMS, so is the system that ensures the traffic management and the protection of the system, so the safety. And we are developing ATO, so the technology for automated operations, built on ERTMS fundamentally, so that in the future, this technology will be applicable in all European Union member states. As you know, the 27 member states have different systems. To give you an example, between London and Amsterdam, a Eurostar train has on board 7 systems. So we need to get rid of this because the cost and the inefficiency that are coming from this type of approach. So ERTMS will be the solution for this, and we will build upon this technology. Similarly, we are working on telecommunication protocols together with the UIC and the industry to develop the new digital communication based on 5G, and once again on a one single telecommunication system applicable in the full European network. So the logic is that working together in a program of research innovation such as Shift to Rail, working together at 27 member states, it allows to reduce the cost of the developments and to focus on the concept of a shared vision on how to operate the rail system, because this is really the key concept, is how we intend in Europe to operate the rail system. It's a bit different for the, let's say, transit or for a metro system, because as has been explained many times, it's a closed system, but we are looking at the opportunity also there to harmonize. I will not use standardize, but at least harmonize, and this is, I think, a major discussion, because don't forget, and one of the reasons also why automation maybe take longer to come to the market, the rail system has a long life cycle. We are talking about vehicle with a life cycle of 40 years. We are talking about infrastructure with 100-year life cycle. So with the introduction of more and more digitalization and automation, we will reduce the life cycle of these assets, and we will speed the inclusion of new technology at a faster pace.
Thank you. Thank you so much. That was very interesting. Unfortunately, we don't have time left, so we have to wrap up now. Thank you, everyone, for taking part in this discussion. That was great. And I invite you to stay on and continue attending the other panels that we have. Thank you so much.
Thank you.
Thank you. Have a nice evening.
Thank you. Bye-bye.
Thank you, everyone.
Bye-bye.